Please welcome Vice President of Artificial Intelligence and Machine Learning Services, AWS, Bratin Saha.
Good afternoon, everyone. Welcome, and thank you for joining me for the AI/ML leadership session. I'm Bratin Saha, VP of AI/ML at AWS. When I earned my PhD in computer science, machine learning was just starting its evolution from an academic pursuit to what it's today, a critical component of every company's business strategy. Now, at Amazon, we have been at the forefront of this machine learning evolution through Alexa, Amazon Go, Amazon Prime, Amazon.com, and others. In fact, every time someone buys something from Amazon.com, it goes through one of our machine learning services. I'm incredibly proud of what our machine learning teams have done at a scale and complexity that's truly unprecedented. Now, at AWS, we have channeled this deep expertise of deploying machine learning at scale to create the AI and machine learning services for our customers. And today, more machine learning happens on AWS than anywhere else. And I've had the privilege of helping our customers use our AI and machine learning services to extract uncommon insights from the data and then use those insights to drive better business outcomes. In this journey, I also had the opportunity to help build one of the fastest growing services in AWS history and learning many valuable lessons along the way. One of those lessons is that machine learning is not the future that we need to plan for. Machine learning is the present that needs to be harnessed now. And so in this talk, I would like to talk about why machine learning is critical to innovation today, how we think it's going to evolve in the future, and what that means for every company in every industry. Let's start with some data on the progression of machine learning. According to IDC, the global spend on enterprise AI/ML has gone from virtually zero in 2013 to $50 billion in 2020, going from zero to $50 billion in just 7 years. By comparison, cloud computing went from zero to $50 billion in almost 12 years, or almost twice as long as machine learning. Now, this investment in machine learning is happening because it will help us solve important economic and social issues. And this investment is apparent in the way our customers are adopting machine learning. Today, more than 100,000 customers across virtually every industry, such as Capital One and Fidelity in financial services, Philips and Novartis in healthcare, Amazon.com and Mercado Libre in retail, Formula One and NFL in sports, Bayer and Siemens in industrial, and many, many other companies are using the AI and machine learning services on AWS and getting significant business results. So as machine learning takes off, many people ask us, how will this all play out? And so I want to use the rest of this talk on the 4 key drivers of machine learning innovation, why we think these are the key drivers for machine learning innovation, and what that means for all of us. First, machine learning will solve problems that could not be solved before with software and analytics and big data. And in fact, machine learning will push the frontier in ways that many of us could not even imagine before, making the world a safer, smarter, and healthier place. Which leads to the question, what is it about machine learning that makes this true? Now, before machine learning, You could analyze tabular data and extract information from it. For example, you could look at your historical sales data and predict your future sales. And you could do that because tabular data has a nice structure to it. So you can write a software program, you can write programmatic rules to extract information from the tabular data and to act on that information. However, most of the data in the world today is not tabular data. In fact, more than 80% of the data generated in the world today is unstructured data. It's audio, it's video, it's text, it's images, it's 3D point cloud. And so most of the information and most of the insights that we want to extract today is embedded inside unstructured data. And as a result, you cannot use software and traditional analytics to do that because it's very hard to write programmatic rules to extract information from unstructured data. Think of a physician. A physician needs to extract insights from MRIs, from X-rays, from patient prescriptions. You can't write a software program to do that. And so these had to be done manually. Now with machine learning, not only can you extract insights from structured data, but more importantly, machine learning can help detect patterns in unstructured data, and at a fundamental level, machine learning takes inspiration from the learning process in the human brain. And so just as we humans can read text, can look at videos and look at images and listen to audio, and extract information and insights from it, and then act on that information, just like that, machine learning can read text, can look at images, can look at videos, can listen to audio, and extract information and insights from it, and then act on that information. And that is what makes machine learning uniquely capable of solving problems that could not be solved before. To illustrate, let's look at a few customer examples of deploying machine learning at scale in the real world and how these customers are pushing the frontier in their domain. And let me start with computer vision, which deals with extracting information from images and videos. In many parts of the world, the kinds of government-issued IDs that are used for loan applications aren't easily available. And so servicing the loan applications of these individuals who do not have government-issued IDs can be very difficult and can get dragged on for weeks. And it's to serve these people that Ayala Credit, a digital financial services company operating in sub-Saharan Africa, was created. By using facial recognition technology from Amazon Rekognition, Ayala Credit is able to verify applicants even when those applicants do not have other kinds of IDs. And in fact, by using Amazon Rekognition, Ayala Credit has been able to extend credit to more than 2 million individuals and micro businesses, many of whom would not have had access to credit. And this is making a big change to their lives. Now, customers are pushing the frontier in computer vision in other ways as well. For example, many customers today use automated ways of extracting information from different kinds of IDs, like your passport and your driver's license. But the problem is today's automated solutions use specialized templates. And so these automated solutions do not work well across different kinds of IDs, like across your passport and your driver's license. And that is because these IDs have different formats. So the template does not work well across different formats. Consider the case of Curative. It's a COVID-19 testing company. Curative needs to extract information from both your ID and your medical insurance card to be able to process insurance claims in compliance with HIPAA. Now, Curative wanted to build an automated solution, but found that it doesn't scale. because it doesn't work well across different kinds of IDs, which differ in format from state to state, and sometimes even year to year. And so I'm very happy to announce an extension to Amazon TextRact that lets customers extract information automatically from different kinds of IDs. With these enhancements to Amazon TextRact, customers will now be able to extract information from different kinds of IDs, like passports and driver's licenses issued in the United States, in a fully automated manner, in near real time, and with very high accuracy. And these features use machine learning to understand the context of the IDs, and then use that understanding to extract different information, like your name, your date of birth, the expiration date of the ID, and so on. And using these features, companies like Curative are now looking to automate ID analysis and improve their business process workflows. Another big domain that is being transformed by AI is natural language processing, which deals with extracting information from texts and documents. And in fact, natural language processing was a largely unsolved domain before AI came into the picture. But since the advent of AI, there has been a sea change in how customers are starting to use natural language processing. Take the case of Slack. Slack has a feature called Clips that users can use to upload voice and video clips into any Slack channel. Slack uses Amazon Transcribe, one of our language AI services, to caption these clips so that users who are hard of hearing can have a more meaningful Slack experience. And not just that, these captions are searchable, which means they increase the organization's knowledge base. Getting to healthcare now, there are so many frontiers to push. For example, Cerner is using machine learning models on SageMaker to predict patients who may be at risk of opioid use disorder. To talk more about this, I would like to welcome Ashley George from Cerner.
Hello. Hi, I'm Ashley George, Vice President of Clinical Products at Cerner Corporation. Cerner is responsible for helping to provide healthcare information technology to caregivers around the world. We have been working to improve the electronic health record for over 40 years, helping to ensure that caregivers have the right data, the right information to best care for their patients. As we approach machine learning, some of the things that we think about at Cerner is to ensure that we're thinking about machine learning to provide new insights and information that could be presented to our caregivers in near real time. We look at all the information that's coming from the vast information about our patients, and how could we use this information for new insights about our patients to be able to help predict or even prevent treatment in the future. As we think about this as well, we're thinking about how can we use these predictive information to lead us to new diagnostic and information for our patients. And ultimately, we want to make sure that any of the machine learning information we're bringing forward, we present it in a way to our caregivers at the point of care so that they can intervene right at that point of time. So let's now talk about one of the real-life examples around opioid use disorder. For those of you who have probably seen in the news, maybe you have loved ones or family members, or even you've been a caregiver for someone who's been impacted by the opioid crisis. It's a very sombering topic, but very real and relevant. It is estimated that over 16 million people around the world are afflicted with an opioid use disorder. And yet, of that 16 million, less than 10% are receiving treatment or being able to intervene for this disorder. And of that, then we see a staggering number of deaths that continue to occur because of the opioid crisis. So at Cerner, we asked ourselves, could we apply machine learning and be able to think about this differently, or how can we best intervene and be able to help advance and think about the ways that we can use machine learning as a predictor? So that's what we did. We created an opioid use predictor disorder for us to be able to think through and be able to have the information come forward to our caregivers. Built within the Amazon SageMaker, we took variables, different types of data, over 40 different data from the electronic medical record, and we're targeting the emergency department so that when a clinician is presented with an information from their patient, they're able to see this information and see if they're at a high risk for needing to have any type of treatment. This is currently in validation at our testing partners, and we anticipate that it will be generally available in 2022. So now, let me take you through a little bit of the workflow. If a patient comes in through the emergency department, what is occurring is then the patient is being cared for and triaged by the caregiver. Information is already collected about this patient, and through this, an algorithm is generated through the machine learning and presents a score to that caregiver. From here, based on the risk or how high the score is, the caregiver then is able to intervene at that point in time and recommend the appropriate treatment path for that patient. This is, for us, the ability for how we can once again intervene early and help reduce any type of opioid disorder events or any other types of patients' harm. Once again, this is just one example in terms of how we are thinking and approaching and using machine learning. We believe that there are endless amounts of possibilities of how machine learning can help to continue to improve outcomes, not only for our patients, but help our organizations to also improve operational and financial outcomes. Thank you.
Thank you, Ashley. Truly extraordinary work at Cerner. Now, part of having a good life is not just having good health, but also having fun, relaxing, and knowing more about the world around us. And as you may have guessed, machine learning is also pushing the frontier there. Discovery is a great example of a company that's using machine learning to push the frontier on user experience. Discovery recently launched their first direct-to-consumer service called Discovery Plus. And the team had a challenge. They had 20 million customers, more than 2,500 shows in 220 countries and 50 different languages. Discovery knew that their human editors alone could not curate the content and provide a good, tailored experience to the users. And therefore, Discovery turned to Amazon Personalize, a fully managed service that lets you build your own recommendation system in a fully managed manner. And Discovery used Amazon Personalize to build a recommendation system for the Discovery Plus app and was able to increase user engagement by 3x. Like Discovery, many other customers have similar ambitions of increasing their audience engagement. But these customers tell us that today's personalization tools that they use are just not accurate enough because they do not keep up with changing user preferences. And therefore, we are launching 2 new additions to Amazon Personalize that address the needs of these customers and further push the frontier on user personalization. The first is pre-built recommenders for Amazon Personalize that provide popular recommendation capabilities in a fully turnkey manner. These are recommendation capabilities like top picks for you, Think of a situation where the person has seen a movie, and you want to get a list of movies that would be most relevant for this person. Now, customers want their marketing professionals, their website managers, their online merchandising managers to use personalization without having to become an expert in machine learning. And to address these personas, we added these pre-built recommenders into Amazon Personalize that can be used in a fully turnkey manner without needing to know any machine learning. And Amazon Personalize does all of the heavy lifting of training models on your data and then hosting your recommendation system so that your product recommendations remain fresh even when the user behavior changes or your product catalog changes. The next is user segmentation in Amazon Personalize. Now, many users want to provide highly tailored marketing messages so that they can engage their users and increase the user conversion. However, unfortunately, today's user segmentation tools are based on static, predefined rules, which means today's user segmentation rules do not keep up with changing user behavior. And as a result, customers have to spend a lot of time tweaking these rules to keep up with changing user behavior. With user segmentation in Amazon Personalize, you can now engage your users even when their behavior changes dynamically. And you can use user segmentation to categorize your users into different categories based on the preferences in things like movies, or even product genre, or even product metadata. And you can use this to create highly personalized marketing campaigns that engage your users more and ultimately improve your user conversion. Now, machine learning can be equally powerful in running cloud applications, because applications running in the cloud can sometimes have anomalous behavior, like increased latencies or increased error rates, due to a variety of factors. Now, in the cloud, it's easy enough to log all events, but it can be daunting to use these logs, to use these event logs, to find root causes of anomalies, because you may end up logging millions of events per hour. And so essentially, you end up trying to look for a needle in a haystack. And that is also where machine learning shines. That is why Amazon DevOps Guru uses machine learning models informed by years of Amazon and AWS operational experience to automatically find anomalies in your AWS applications. And not just that. When Amazon DevOps Guru finds anomalies in your applications, it gives you a list of potential root causes, and it gives you a list of possible remediations so you can fix your applications quickly. Let's look at a customer example. 605 is a TV advertising measurement company that helps customers optimize their TV advertising and reaches more than 21 million US households. 605 had more than a dozen AWS accounts and tens of thousands of AWS cloud resources, and they were having a hard time correlating the metrics across all of these AWS resources. And therefore, they turned to Amazon DevOps Guru, which uses machine learning models to help them root cause issues in their applications. And using Amazon DevOps Guru, 605 was able to significantly reduce the mean time to application recovery. Now, another industry that generates a lot of data is the manufacturing industry. In fact, applying machine learning to sensors and other data generated by industrial equipment can be a game changer in the manufacturing industry. Let's look at a customer example. Koch AG and Energy is a wholly owned subsidiary of Koch Industries, one of the largest private companies in the world. Coke AG wanted to be able to proactively detect potential failures in their equipment. And therefore, they turned to Amazon Monitron and Amazon Lookout for Equipment, two machine learning services that can proactively detect potential failures in your equipment and alert you to them before these impact your users. In fact, by using Amazon Monitron and Amazon Lookout for Equipment, Coke has been able to find potential failures in their equipment hours before any other monitoring method. For example, Amazon Monitron was able to alert Coke to a potential issue in one of the nitrogen-producing units by detecting abnormal vibrations using machine learning. Now, more and more, the use cases that we have been talking about rely on data from sensors, from cameras, from robots, and from other edge devices that are located in places far away from a data center. But these devices capture massive amounts of data, audio, video, images, and so on. And so customers are very interested in doing machine learning on the data being captured in these devices. But unfortunately, it's often not feasible to upload this data to a data center because of bandwidth limitations in a remote place. And so AWS provides you services that lets you do machine learning on edge devices, the newest member of which is AWS Panorama. AWS Panorama is a machine learning appliance that lets you do computer vision on on-premises IP cameras and lets you analyze your video feeds in just milliseconds. Take the example of the Port of Vancouver, which is the third largest port in North America. The Port of Vancouver is using AWS Panorama to automatically track containers through the entire inspection process in the port. Now, before starting to use AWS Panorama, the Port of Vancouver used to get a lot of complaints from the users because of delays in the inspection process or because these users did not have good visibility into the status of the inspections. And that was because the inspection process was largely manual. So the Port of Vancouver, in partnership with Deloitte, decided to automate this inspection process. And since this inspection requires looking at the containers and its contents and its conditions, the Port of Vancouver decided to use on-premises camera and turn to AWS Panorama. By using AWS Panorama, the Port of Vancouver was able to automate the tracking of containers through this inspection process and therefore reduce the amount of manual data entry in the inspection process, was able to improve the data reconciliation during this inspection process, and provide near real-time updates to the key stakeholders. And all of this reduced the wait time and improved space utilization at the port. Now, I wanted to discuss these real-life customer examples of using machine learning at scale to explain why machine learning is critical to innovation today. But as more people start doing machine learning, we need the fuel to keep the fire going. And for machine learning, that fuel is data. All of this machine learning will need tons of multimodal data, audio, video, text, tabular, images, 3D, and so on. Which brings me to the second key driver of machine learning innovation, and that is enabling the processing of massive amounts of multimodal data. Let's look at some customer examples of multimodal data processing at work. The NFL has partnered with AWS to create the Digital Athlete Program that uses machine learning to track helmet collisions and identify risks during games. This requires labeling hours of video footage so you can train machine learning models to automatically track helmet collisions and identify risks during games. Thomson Reuters has more than 150 years of rich data on tax, on law, on news, and other aspects. And they want to use this data to train machine learning models. For example, Thomson Reuters is today using tens of thousands of documents to train machine learning models to do natural language question answering. And Intuit has more than 275 million minutes of customer conversations every year that they want to analyze to gain insights. And Aurora uses simulations to generate massive amounts of video and 3D data that they use for training highly accurate perception models for their autonomous driving. Now, to create machine learning models from this data, all of these customers need to label this data. And as the demand for machine learning has grown, so has the demand for data labeling. Now, today, customers often use teams of data operations managers or program managers to do the labeling work for them. But these teams have to manage the labeling workforce. They have to set up the data labeling jobs. They have to validate the quality of the labeled data. And all of this can be daunting, especially when the volume of data has grown. And therefore, we are launching SageMaker Ground Truth Plus, which provides a fully turnkey experience for data labeling. Here is how SageMaker Ground Truth Plus works. As a customer, you bring your raw data, and you give us your labeling instructions. And then Ground Truth Plus takes it over from there. It looks at your labeling instructions. For example, if you want your data to be labeled by experts in video labeling, Ground Truth Plus will only send your data to workers who are proficient in video labeling. It then manages the workforce on your behalf. It does the automation of the labeled data on your behalf, and then hands back the labeled data to you. In essence, you hand it the raw data, and Ground Truth Plus gives you the finished, validated output back to you. And not just that, Ground Truth Plus embeds machine learning into data labeling. So for example, Ground Truth Plus uses machine learning models to pre-label the data so that human labelers don't have to do any more labeling. They just have to verify that the labels being done by the machine learning models are correct. And this can reduce the cost of data labeling by up to 40%. Now, as we think of all these transformative use cases, it's natural to ask, how do we make sure that more people can do ML? How do we make sure that machine learning is not just restricted to machine learning scientists and data scientists, but is more broadly accessible so that more employees can be part of the machine learning transformation? And that brings me to the third key driver for machine learning innovation, which is empowering more people to do machine learning. According to the LinkedIn Jobs Report in 2020, the demand for AI and ML practitioners has been growing by 74% annually for the last 4 years, more than 2x that of any other job category. And given the early nature of machine learning, it's no surprise that customers are having a hard time hiring all the people that they need to hire to get all of the machine learning done. And so these customers asked us, can you expand the audience for machine learning? Can you provide us tools that make it easier for more employees to do machine learning? And that got us thinking, how do we change the paradigm fundamentally so that machine learning can be done by data analysts, by sales and marketing professionals, by HR and finance professionals, employees who use data, who understand data, who would benefit from machine learning insights? And we came up with a novel solution. But before I get into the solution, let me give you an analogy to explain how we have been thinking about this. If I can take you back to the late 90s when the internet boom started, creating a website then wasn't easy. You needed to write a bunch of HTML code, and only coders could do it. And then came a set of no-code tools that let you build websites. You could just point and click and drag and drop and build your own website. And boom, there was an explosion in the number of websites. Some estimates say today there are more than 2 billion websites. And that got us thinking, how do we change the paradigm and make it possible to build and deploy machine learning models without having to write any code? And that gets me to Amazon SageMaker Canvas, a no-code extension of Amazon SageMaker that lets you build and deploy machine learning models without having to write a single line of code. Canvas makes machine learning accessible to data analysts, to other employees in a company who may not be proficient with coding, who may not be proficient with machine learning, but who nevertheless want to use machine learning and benefit from its insights. And with SageMaker Canvas, users can access multiple sources of data on premises or in the cloud. And then Canvas will automatically build the right models for them, will train the models for them, will deploy the models for them. And all of this without having to write a single line of code. In effect, we completely redid SageMaker for a new customer persona. To show how Canvas works, I would like to invite Kimberly Mardia from the AWS product marketing team.
Thank you, Broughton. As a product marketing manager, I deal with a lot of data every day. I need to use this data to measure the impact and effectiveness of my sales and marketing campaigns. For example, I look at visits to my web page and try to figure out among all those who visited, who are the right people to offer promotions to. Now, I know machine learning is the way to go, but I'm not a machine learning practitioner, so I don't typically build, train, and deploy machine learning models as part of my everyday job. More specifically, here's my problem. I need to be able to predict if leads in my marketing pipeline will convert and become paying customers or not. And now, with Amazon SageMaker Canvas, I'm able to generate these predictions all on my own, even though I don't have much experience with machine learning. So let's dive in and see how it works. The first step is for me to connect to the SageMaker visual experience and connect to the data sources containing my sales and marketing data. And SageMaker Canvas will automatically discover the data sources that my account has access to, such as Amazon S3 and Amazon Redshift. And I'm also able to drag and drop files from my local computer into SageMaker Canvas. And that's not all. Canvas also comes with built-in connectors to third-party data sources. Now that I've connected to my data sources, the next step is for me to create a single unified data set that I can use to train my prediction model. In this case, I'm going to join some web traffic data with customer information in Amazon S3, such as the unique lead identifier. I'm able to visualize this data join to make sure that it was correct and that my data is ready for machine learning. And SageMaker Canvas makes this very easy for me to do because it will automatically detect incorrect errors, such as filling in missing values or removing duplicate rows and columns. The next step is for me to specify the target that I want to predict. In this case, if a lead will convert and become a paying customer or not. And I'm able to do that very simply from a pull-down menu in SageMaker Canvas. Now that I'm ready to go, SageMaker Canvas will automatically generate my model for me based on my use case and based on my data. I I can see in this case that my model has an accuracy of about 90%. And I feel really good about this for my use case, so I'm going to go ahead and put this model to work for my sales and marketing campaigns. The first step is for me to go into the Analyze view and explore all the different model inputs that went into making the prediction. This is known as model explainability. And model explainability is super important for me because I want to earn trust and better collaborate with my stakeholders by explaining the how and the why of my prediction. In this case, I can see that if a lead participated in a promotion, they are very likely to convert and become a paying customer. So let's see what happens if I offer a promotion to a particular lead in my pipeline. And I'm going to do this by performing a what-if analysis. I simply change the promotion field from no to yes, and I can see that the prediction changes from not converted to converted. Therefore, it makes a lot of sense for me to work with my sales and marketing colleagues to put together a promotion for this lead in my pipeline. And that's not all. I'm able to share my models and my data sets with the data science teams who are using Amazon SageMaker Studio. This is really important because I definitely want to make sure that my models are compliant with corporate standards and guidelines, and I also want to get some really helpful information so that I can improve my model. In this case, the data science team realized I was missing an important data set, so I'm very easily able to add that to SageMaker Canvas to improve my models. So overall with SageMaker Canvas, I have everything I need to build machine learning model predictions all on my own. And I'm able to collaborate with my stakeholders by explaining the how and the why of my predictions so that I can better meet my business goals. And Broughton, I'm sure you'll be very happy to hear we now have a machine learning-based approach to our marketing campaigns. Thank you very much.
Thank you, Kimberly. I think Canvas will be a game changer in making machine learning accessible to more employees. But we are doing even more to help people get started with machine learning. And so therefore, to help students and other people who want to get started with machine learning and just want to experiment with machine learning, we are launching Amazon SageMaker Studio Lab, a no setup, no charge machine learning environment. Studio Lab provides you a Jupyter notebook integrated with GitHub and then packaged with all the popular machine learning tools so that students and others can quickly get started. In fact, you don't even need an AWS account to get started. You can just use your email address to get started with Studio Lab. And Studio Lab not only gives you free compute, it also gives you free storage. And then when you're done with your work, you don't have to worry about shutting down your instances or saving your model or saving your data, because Studio Lab does all of that for you. It's as simple as closing your laptop and then coming back to it again and resuming your work when you want to. We have many ways to help you get started with Studio Lab, including a chance to enter the Guinness Book of World Records. Starting today, you can enter the Studio Lab Hackathon, and this is a special event because we're trying to create the world's largest virtual hackathon. We are looking for 5,000 hacks, so I hope you will join us there. I'm excited about how Canvas and Studio Lab are going to make it much easier for people to get started with machine learning, especially those who are early on in the machine learning journey. But to get to business value, machine learning needs to get integrated into every aspect of a company's operations. And that gets me to the final key driver of machine learning innovation. And that is industrializing machine learning to scale its deployment. We have seen this industrialization play out in other industries as well. The automotive industry is a great example. The assembly line industrialized automotive design and manufacturing and moved us from one-off handmade cars to mass-produced cars, effectively launching a revolution in transportation. The software industry went from a few specialized business applications to becoming ubiquitous in our lives through automation, through standardized tooling and standardized processes. In effect, through the industrialization of software. And just in that way, machine learning also needs to industrialize. And at AWS, we have been at the forefront of that machine learning industrialization. To set some context, let's look at how machine learning has grown. On AWS today, customers deploy millions of models, and they train models with billions or tens of billions of parameters. And they make hundreds of billions of predictions per month. So when we are talking about millions and billions and hundreds of billions, that says machine learning is no longer a niche and has to industrialize. Now, machine learning industrialization has three components. First is an infrastructure that is tailor-made for machine learning so that you can get the best performance and cost. Remember, if we are talking about producing millions and billions of something, you need an infrastructure that can produce it quickly and produce it at low cost. The second is machine learning tools. And these are tools that are purpose-built for machine learning so that they can reduce the heavy lifting in the machine learning workflow. These are tools like machine learning IDEs, like machine learning bias detection tools, like machine learning project management tools and debuggers and profilers and so on. And all of these are integrated into a cloud-based machine learning service so that you get the best and most performant, cost-effective ML infrastructure. And the third is automating your machine learning workflow, also called MLOps. Let's look at each one of these, starting with machine learning infrastructure. On compute infrastructure, we have been releasing more performant and better GPUs and custom processors so customers can do faster and cheaper machine learning model training and inference. On training, just yesterday, we launched AWS Trainium, the second custom-built machine learning chip from AWS. AWS Trainium will provide the best cost performance for training machine learning models in the cloud. And I think will be a game changer for training deep learning models in the cloud. For GPUs, our P4D instances continue to remain the most powerful GPU instances in the cloud, improving performance by up to 2x and reducing cost by up to 60% over the previous generation P3 instances. And just this year, we also launched the EC2 DL1 instances, which are based on the Gaudi processors from Habana Labs, which reduce price performance by almost 40% over comparable GPU instances. Now, for inference, many of our customers continue to benefit from AWS Inferentia, a purpose-built chip from AWS for machine learning inference. In fact, customers like Airbnb, Prime Video, and Sprinklr get up to a 70% lower cost and 2x higher throughput than comparable GPU instances by using AWS Inferentia. And finally, our G5 instances that we also launched this year provide up to 3x higher throughput than the previous generation G4DN instances. But machine learning infrastructure is not just about hardware optimization. It also requires software optimization. Think of customers who have intermittent workloads, like restaurant recommendations from an online food delivery service. They don't need that recommendation to be running at midnight when no one is ordering food. And so these customers today create complex workflows to shut down their instances when there is no traffic and then to quickly bring these instances back up when there is traffic. And so therefore, I'm pleased to announce SageMaker Serverless Inference, a fully managed serverless offering from SageMaker. SageMaker Serverless Inference will automatically allocate an instance for you based on the needs of your machine learning model, then elastically scale it up and down based on the traffic, and best of all, it's pay per use, which implies no traffic means no charge. Now, infrastructure makes your machine learning faster and cheaper. But machine learning tools and machine learning ops make your machine learning easier. They make your ML developers much more productive. And SageMaker provides you an integrated set of capabilities inside SageMaker Studio that make it much easier for developers to do machine learning. Let's see how customers are using these. Vanguard has been able to automate their entire machine learning workflow using SageMaker, and they have been able to reduce model deployment time by 20x. AstraZeneca, by using SageMaker, has been able to reduce the time to deploy their machine learning environments from 1 month to 5 minutes. From 1 month to 5 minutes. NerdWallet has been able to reduce their machine learning training time by 75%, even when they have increased the number of models they're training. And Zendesk has been able to reduce their cost by almost 90% for inference. So customers are clearly getting a lot of benefit even today. But we want to do even more to help customers get more productive with machine learning. So let's start with model training. Today, many customers spend a lot of time, weeks to months, to optimize their models. And they have to do this because there's a lot of craftsmanship involved in optimizing these models, because these models can have billions of parameters. And therefore, we are launching the Amazon SageMaker Training Compiler, which automatically optimizes your models for you and gives you up to a 50% performance improvement. The SageMaker Model Compiler comes integrated with the default versions of TensorFlow and PyTorch, so that users of these popular packages can use the compiler by default and get its performance benefits. Now, I talked about machine learning, building, and optimizations. But customers still have to do a lot of manual work for machine learning deployment. For example, today machine learning engineers have to choose from over 70 instances to figure out which instance they want to do machine learning deployment on. Then they have to configure that instance. Then they have to run load tests on that instance. And then they have to optimize their model on that instance. All of this takes weeks of manual effort, ultimately delaying model deployment and time to market. Therefore, we are announcing the SageMaker Inference Recommender that reduces the time to deploy models from weeks to just a few hours. The SageMaker Inference Recommender will automatically pick the right instance for you that gives you the optimal cost and performance, optimize your models for you, run load tests for you on the instance, and then configure the instance for you. And so all of that work that took weeks of manual effort now gets done automatically in just a few hours, which makes machine learning deployment much, much easier for customers. Finally, let's look at the third component of machine learning industrialization, which is MLOps. And MLOps lets you do several key operational requirements. For example, it lets you automate your entire machine learning workflow and make it repeatable so that you don't introduce errors. It lets you enhance your governance and audit posture so that you make your machine learning more transparent and increase confidence. And then finally, it fosters the responsible use of machine learning so that you can do things like bias detection, model explainability, and model monitoring. And SageMaker supports all of these ML operational requirements through SageMaker Pipelines. SageMaker Pipelines is a fully managed feature that lets you automate your entire machine learning workflow, from processing data to building models to retraining and training models and deploying models. And not just that, SageMaker Pipelines lets you do CI/CD, continuous integration, continuous deployment for your machine learning workflows, just like you would do with software, which makes your machine learning a lot more robust. SageMaker Pipelines also enhances your governance and audit posture because it tracks your data, your models, your ML artifacts at every step of the machine learning workflow and lets you do source and version control. And finally, I'm excited to announce that SageMaker Pipelines now integrates bias detection into every step of your machine learning workflow. So you can detect bias in your data or your models. You can do model explainability. And you can also monitor your models so that you get alerted if there are any quality degradations. One common theme you may have noticed as I was talking about the key drivers of machine learning innovation is that Amazon SageMaker has played a major role in establishing these key drivers of innovation and making them a reality. In fact, Amazon SageMaker is today one of the fastest growing services in AWS history. And we have been amazed and grateful to our customers for the adoption that we have seen. Just in the last year, we launched more than 60 new features and functionalities that, along with everything we launched at re:Invent, makes Amazon SageMaker the most comprehensive machine learning service that lets ML scientists, ML engineers, MLOps engineers, and analysts build, train, and deploy machine learning models. But it isn't just SageMaker where we have been investing. We are continuously innovating and delivering new capabilities in our language AI services, in our vision AI services, in our health and industrial AI services, in our AI DevOps services, in our personalization and forecasting services. So together, our AI services, along with SageMaker, along with ML frameworks and infrastructure, are enabling hundreds of thousands of customers to transform their business with machine learning. Let me conclude with the main takeaway from this session and bring you back to the lesson that I talked about at the beginning of this talk. And that is, machine learning is no longer the future. Machine learning is the present and here and now. And based on Amazon's own experience and the experience of more than 100,000 of our customers, you can also transform your business through machine learning by using the 4 key drivers of machine learning innovation. First, use machine learning to solve problems that you could not solve before. Second, enable the processing of massive amounts of multimodal data. Third, empower more employees to build machine learning. And finally, industrialize machine learning across your business so you can scale machine learning deployments. To learn more about the features that we are launching at re:Invent, please visit the AWS Machine Learning website. And don't miss the deep dive AI ML sessions, chalk talks, and workshops the rest of this re:Invent. Thank you for coming, and enjoy the rest of re:Invent.